again, everyone. So let's just get started. It's been an amazing time. We've been on Python for data science for over the course of 2 weeks, and now this is the third week. We'll be wrapping up by Wednesday, and today we'll be looking at we'll be continuing from where we stopped last class. Last class we stopped at indexing. We stopped at Pandas indexing. I just want to navigate to the place. We did indexing and selection last class, filter, sort, and group by. So today we'll be looking at joining and concatenation, dealing with missing values, and then we'll be doing some data exploration. And as well, I'll be introducing you to data visualization. So hopefully we're able to cover all of this today so that on Wednesday, we're going to go through our project walkthrough, what you're expected to do for your projects. So you have till the last week of July to submit the projects. All right, so you have some time to go over it and do, and I'll be showing you what you're supposed to do on Wednesday. So ensure you don't miss Wednesday's class so that you can get all the necessary information regarding the project. All right, so let's get started with what we have for today. Let me navigate to my notebook. All right, so we looked at last class. Let me just go back to last class so that you can you can have an overview of what we did last class. Let me go back to last class notebook. Okay, so last class we looked at how to filter records. We've been talking about Pandas, and Pandas is a data manipulation tool. And if you've not been following through from the beginning of the class, this is like a continuation of what we've been doing for over 6 classes. So this is class 7 for the data Python for data science beginners program. So try as much as possible to follow through from the beginning to the last class so that you'll be able to be on the same page with what we are doing. All right. So last class we looked at how to filter records, how to group records, and how to sort records within a table. So this is where we stopped last class, and I took you all through the basics of what you're to do. So we'll just go right into merging and joining. So when you're dealing with tabular data, and most especially most times within organizations, you have most of your data sets in different tabular in different tables. You would not, it's rare for you to see a single data on the same table. I would explain what I mean by that shortly, very quickly. If we are joining, I believe you're joining with our name or our email address. There's somebody that is trying to join, but I can't read. It's an Arabic name. I can't read the person's name, so unfortunately I won't be able to admit the person. All right. So please, whenever we are joining, let's just like we usually do, our name or our email address so that we can verify who you are. Okay, so we'll go right into the merging and joining and concatenation shortly. Whenever you're dealing with any tabular data, usually you'd get to have your data in different tables. For example, if you're dealing with a database related to maybe a university database, for example, let me use something that we can all relate with, a university database, and you need to, do some data analysis on their data sets. Usually you have different colleges, or depending on the kind of university, if you have college, the universities are some universities are divided based on faculty, colleges, schools, depending on the kind of university. So you have most of those records in different tables. And even within a faculty, you have different data sets for maybe within the faculty, you have the HODs, you have the lecturers, you have the students record, you have the students maybe the first semester exam, second semester results, all of those all of those records, they might be scattered around different tables. And so the idea of combining tables when you want to do your analysis is very, very key. You have to understand, how do you combine records? When do you combine records? When you combine the record, at what point? I mean, how relevant is the combination of the record to what you're doing? So all of those things, that's what I'm going to explain in merging, joining, and concatenation. And I'm just going to use a very simple case because I won't want to bring a very complex, real world data to explain it, so that we can all follow through and understand what we mean by merging, joining, and concatenation. All right. So I just thought to give that background so that you will be able to, understand what we're about to do. Okay, so we'll just get right into that. Sorry, just a minute. Please, let's try to join early so that we won't disrupt the class. If we join on time, we'll be able to move as fast as possible so that we don't have to disrupt the flow of the class. All right. So okay, like I was saying earlier regarding the merging, joining, and concatenation, you would have to understand that when you're combining, it involves combining different tables together. Now, in this simple case, we have a pandas. We have to import our pandas because it's pandas we want to use to manipulate the data. Then let's create a dictionary called name and age. This dictionary is it's in form of our key and our value pairs, just like we learned during our dictionary class. All right, and you can use a dictionary to create a data frame. That a data frame is a way of converting your dictionary to a tabular data in Python. All right. So when you do pd.dataframe, the name of the dictionary, you're able to convert this into a table. All right. So here, taking a cue from that, we are here, you're creating like three different tables. three different tables and in three different data frames. I mean, in three different data sets. We have DF1, DF2, and DF3. So I'm just going to run it so that we see what the output is like. Okay. So having these three different tables. Now let's study the table that we have. These are just dummy data. So we'll be walking through, when I take us through the basics of what we have, how to use our data manipulation skills, right? We'll be working on a real life example so that we can relate to what we've been discussing over the two classes, Pandas. All right. So on this table, you can see that we have columns with A, B, C, D. So the columns could be maybe first name, last name, maybe age or date of birth. These are just variables just to depict what I want to explain. All right. So we have the column A, column B, C, and D, and then we have row 0, 1, 2, 3 for this data frame. So the difference between these two data frames is just the elements inside each of the data frame. You can see that this is A0, B0, C0, D0, A1, B1, C1, D1, and all of that. And this one as well, we have A4, B4, C4. But I just want you to take note that these data frames, right, they have the same column names. They have the same column names. All right. I just want you to take note of that. That attribute of these three data frames. Now, there are three ways by which you can join different tables together. So you can think of this first data frame as maybe a table that holds maybe the student's name, matric number, matriculation number, or maybe department or just students' data. Let me use that as an example. You could think of this one as the one that holds maybe the departmental data, and you can think of another one holding maybe the course data, right? So if you want to join these three tables together, how do you join them together? Sorry, I'm having some persons at the lobby and they are having issues, joining. So I'm trying to get them in. Please, let's try to join on time so that we don't disrupt we're recording it so that we don't disrupt our recordings. From the next course, we might have to be strict with attendance. Might have a time where we have to lock the class so that we'll be able to just focus on what we have for today and fix so that we can meet up with the time frame. All right. So there are three ways by which you can join tables together. There's something called the concatenation. So concatenation involves you gluing data frames together. You're joining them based on axis. Let me use that word. I'm going to explain what axis mean. Axis we have axis 0 and axis 1. So axis, when you're joining based on axis 1, you are joining based on the rows, the column join. That is, you're combining the data sets. This is it. You're combining it across the columns. All right. But then if your setting axis equals 0, that's the row stack. You're stacking as if you're stacking these three tables together. For example, if you're concatenating based on axis, when your axis equals to 0, you're stacking 0, 1, 2, 3, then followed by 4, 5, 6, 7, followed by 8, 9, 10, 11. It's just like you have the students' records from the first 4 students' records, and then you're joining it with the next four students' records, and then you're joining with the next 4 students' record. I don't know if you understand what I'm saying. So when you're concatenating along the rows, you use axis equals 0. So by default, if you want to concat across the rows, along the rows, or it's just like you're stacking the tables together on top of each other, right? You use PD, the syntax is pd.concat, then brackets, the name of each of the tables, df1, df2, df3 in square brackets. That's the syntax to join the tables together. By default, this axis is set to 0. pd.concat argument sets the axis equals to 0 by default. So you might not have to include that when you're writing your concatenation and when you're concatenating across the rows. All right. So I don't know if you got that, but I'll explain again further if you don't quite understand that after taking the axis equals 1. Okay. Let me admit some more persons, please. Okay. Let us proceed. Okay, so when you concaten across the rows, right? You're going to do pd.concat df1, df2, df3 in square brackets. By default, this axis is already set to 0, so you might not have to include it. So if you put shift tab in front of this function and you check the attribute of this definition of this function, you can see that the default axis, that's after setting the objects that you want, that is asking you for the tables. This object represents the tables that you want to merge in square brackets, right? Then the next argument is axis equals 0 by default, and it does an inner join by default. So I won't bore you with the remaining details, but I just want you to take note that by default it's axis equals 0. But then you can alter the joining of that record, right? You can alter it and you can say pd.concat df1, df2, df3, axis equals 1. That is, you want to join across the colons. And if when you do it this way, it stacks after after the first, this is the first record. It sets it joins it takes the next table on this row. It takes the next table here and it joins it across the column. You can see that the table has been enlarged. It's a bigger table and it's joined across the columns when you do it's this way. So let me use a kind of data set that maybe it might be easy to relate with. So let me just duplicate this data set. Let me do something like students, maybe students table, students, period of data frame. So we have maybe their first name, Moses, O, what other first name? Um, No name is coming to my mind. Okay, let me use my name, Grace. And Finn. Okay, so given the first name, now let's have another argument called maybe age. All right. I'm trying to, give a real life data set so that you'd see how these things work. So we have students one. Age, you can say, let's give them different ages. Let's say this is 30, sorry, 24, 15, 30, and 40. Let's look at another attribute. Let's say score. 70, 30, 100, and 90. Let's look at another one, grade. Let's do grade. Okay, let's do grade A. These are just dummy data, right? A, B, A, C. All right. So this is the first student table. Assuming you have a table like this, right? Let me print out this table so that you can see what it looks like. Sorry, it's students one. Okay, you can see it's relatable, right? Now you can have it's the first students table like this called students one. So I'm going to duplicate. I'm going to make 3 other tables, student 2 and student 3. So let me just change their names. Let me just I'll use your names. I was trying to just not to use anybody's name. Well, I'll use the people on the lobby because they came late. So I'm going to use their name. Antonia, Joy, Shegun. And there's one person that with an Arabic name. I'm sorry, I can't translate. I don't know the name. Abel, you didn't come late, but then I just use your name anyways. Okay, so let me use another age. Let me just do something else. 19. They might have the same age. They might even have the same grade, but let me just change it so that you can we can have varied data sets, right? So I try to prepare all of the notebooks ahead because of our time so that we don't have to do all of this thing. But then because of the peculiarity of what we are doing, that's why I'm having to, do this here again. All right, so let's have a different index. So this is index 4, 5, 6, 7. All right, let's have other names. Sonia, Joy, Mistura, and Shegun. All right. Welcome to the people that are just joining. So we are working on merging and concatenating tables. So that's what we are working on. This class is a follow-up of the other classes. Okay, so let's get the other names. B-Day, Fortune, Joseph, and Payne. Okay. All right, so let me just leave this data like this. I think it's well varied. Because of our time, let's just get into the description of what we have. 10 and 11. Believe we are familiar with creating data frames. All right, so okay, so we are going to load this. Okay, just a minute. I'm having issues with my view. All right, so we have all the records, set. Now let us load each of those records. So we have the student 1, student 2, student 3. So let me load the each of the records, students 2. For persons that are just joining, we are looking at merging, joining, and concatenation. That is, when you have different tables, how do you bring them together? Because when you're doing data analysis, in real life, you tend to work with different tabular data. It's not just one single tabular data. So you have different tabular data, and then you must know how to join those tables together. And when you're joining, what are things to look out for? Now, in this case, we have this. I think this is easy to relate with, right? Unlike the variable names. Okay, so we have the first students. These are their names, age, score, and grades. Second students table, third students table. All right. So having noted this, if you want to do your concatenation, for example, you want to concatenate this table together. So you can just do pd.concat. Then in square brackets, students 1, student 2, student 3. So I'm going to, sorry, let me just copy the names so that I don't have to type all of the names. Student 1, student 2, sorry. Student 1, student 2, and student 3. All right, so by default, this is going to stack all of those records into, you can see it has stacked all of those tables together into a single table. I think that's quite easy to relate with compared to those variables. All right, so as we progress, right, I mentioned that there are two ways to stack concatenate the tables. You can concatenate across the rows. So what we just did is a row-wise concatenation. That is, we are concatenating each of the students' name on top of each other across the row. Across the rows. Now, if you want to do a column-wise concatenation, you're going to set the axis equals to 1. And when you do that, it's the same syntax, it's the same syntax, right? And when you write, what you're going to just change is that axis equals 1. And when you do that, this is what happens. So you can see the difference between the two. Now you can see that we have multiple first name, age, score grade, first name, age, score grade, and each of these places are vacant because you're concatenating them across the columns. And in this case, for this kind of data sets, right, it's not always advisable to concatenate across the columns by setting axis equals 1, because now you're having missing values in this area. So that's what this one was. I mean, the explanation here was showing us. All right, so I'm going to show you other ways to concatenate, to merge your data. So it's not all the time you use the concatenate period or concatenate. There's another way to concatenate your data sets, and it's called the merge function. The merge function is similar to people that are familiar with SQL. The merge function is actually similar to SQL. All right, so I'm going to explain. It's very, very powerful, and it's also very interesting. So I'm going to explain how you do a merge using another table. If you have questions, please drop your questions in the chat. Would address them during our open forum. Okay, dot append. All right, I will answer the questions when doing our open forum so that I don't interrupt the class, right? Okay, so we have the merge function. Now, the merge function allows you to merge data frames together using a similar logic like SQL tables. For people that have a background of SQL, you understand what I'm talking about. But then if you don't have a background of SQL, no problems. I'm just going to explain what the different type of merge functions are. So the first, I'm going to create another data frame. Now, this is a new data frame. It's different from the other one. So the difference between the first one and the other one is that this new data frame has an ID. It's just like an identity, what's it called now? An ID, right? An identification number for each of the record. Like students in a school or in a college, you have your identity number. Even at work, you have your employee number, which is your identity number. Or in school, you could have your maybe matriculation number, which is your identity number. All right. So in this case, we have an identity number here in this data frame. So let me just try to simulate the other table just like I did so that we can have a very, very relatable explanation. So let me just copy this. All right, let me have it here so that I can, this name is just too long. Let me change it to ST1, ST2. Or now in this case, I'm not going to use ST1. Let me just say ST left so that for the sake of what I want to explain, and ST right. Okay, so here we have before the first name, we can convert one of them to ID number. Let me use the score now. Okay, let me use the score as an ID number. Let me use one. Four. Well, I want the ID number to be the first table. I mean, to be the first column in on my table. So let me just put it here. All right, so we have the ID, the student ID, then the student names, right? Then afterwards, let's use, for simplicity's sake, let's just use the student's age, okay? We might have to remove grade. Let's just remove grade so that to be very simple. What we are doing will be very simple. I might remove the index as well. I don't need the index here because I have an ID already. Okay, so this is a dictionary. So I'm going to close my dictionary. Okay, so let me do the same thing for this one as well. Let me have an ID colon. So I'm going to have, now the ID is the same thing. In this case now you're having two different table. That is, maybe one of the table might be holding the student's first name and last name, and the other table might just be holding the student's score and grade. So here, this second table is still going to hold the student's first name and age. Then the next ID, it will be holding the student's score and grade. All right, so let me delete this age and first name and last name. And let us have the score and the grade. Let me remove the index as well. Okay. I think we are good now. So we have the left and the right table, right? And then when we load it, okay, I have a syntax error somewhere. Something was, okay, I've seen it. There was a missing comma. Okay, now this is the way our table looks like. Let me have it at the bottom here. So we have the ST left and ST right. Okay, so we have the ST left, right, and ST right. Now we can relate, right? Given the names of like maybe this can be the students' bio data table, and then this can be the students' grade table, maybe a grade for a particular course, right? So in a case whereby you're working on a database, you're having two different tables like that. How do you merge them together? And what's the implication of merge using the merge function? So that's what we want to look at now. So the first merge is the inner merge. That's what I want to explain. Now, what the inner merge does is, this is the syntax. pd.merge, pd.merge. The first table, that is the left table, the st left, comma, the st right. Now, there is an how method. If you don't really know all of the arguments, you can just do Shift tab or Command tab on your system to see the details of the definition of that function. Now, it says the first thing you have to apply is the left data frame, and that's the st left, right? The second one is the right data frame, the st right. Now, you have to tell the function, how do you want to do your merge? By default, it's an inner join. I'll explain what an inner join is. Now, the how is set to inner by default. We can just indicate it here so that we can all see. Then, apart from the inner join, then on, what is the common key? What is the common key between the two tables? We can see that the ID is what is, the common key column between the two tables. We want to join them based on the ID. We want to merge the two tables based on their matric number or their identification number or their unique number, right? Their unique column, and that is the ID. So that's the on key that we're going to define here. So on your ID My ID is in cap. Let's take note of the syntax. I mean the capitalization and everything, because that's going to affect our merge function. Now, when you do your merge, this is what happens. Because it's an inner join. So what it does is that it picks the first ID, right? The first name, first name, the ID, first name and age. Then it comes here, first name, and it comes here to check for the key that ID1 has score and grade. So it's going to merge first name, age, score, and grade into a single table. First name, age, score, and grade into a single table, into a single row rather. Then it comes to the next ID. It comes to the next row. The next ID says ID2, right? ID2 is what? Call 15. Then when he's doing his join, he picks the ID that has 2, right? Then you have the 70B. So he puts it on a single line. Let me scroll down to the single line. You can see call 1570B. The same thing, it does the same thing for the third ID and the fourth ID. You can see that these two tables now, they've been joined together on a single, they've been combined on a single table. Now we're going to see some differences when we are doing maybe the outer join and we have the inner join, we have the outer join, and then we have the full join. So I'm going to show you the difference. So this one, the inner join is going to look through each of the ID. It's going to use the ID to look up the common the record for each of the rows. Now it's going to come here, ID1, Moses 24, ID1, 50C. It's going to put them on a straight line. If we have another ID1 somewhere here, right, it's going to come back to say Moses 24, the next ID1, and it's going to put it on a straight line. So we're going to look at another more complex example for the sake of for the sake of explanation. I'm going to look at another example so that we can see it clearly. Okay. All right, I hope we are all understanding. If you're still with me, you can just say yes on the chat so I can know that you're following. The joining can be a bit, complex, but then once you pay some attention to it, you see that it's very, very easy and clear. So having understood the inner join, let me show a more complex example. And in this case, we have, let me use this example so I don't have to recreate another data. We have another data frame where we have the left and the right. But in this case, we have two keys. We have key 1, key 2. We have two IDs now. We have ID1, ID2, A and B. ID1, ID2, A and B. Now, you can see that each of those tables, all what we have on the columns, they are the same names, right? But the contents, each of the rows might have different, the contents, right? So if you want to do a merge, an inner join in this case, how is it going to handle it before we even look at the code? Okay, let me take you through the code. When you do an inner join using these keys as your unique key, right? How are you going to handle it? Now, what it does is that it goes to the first row, K0, K0, A0, B0. Then it comes there, which one has K0, K0? This has K0, K0. So it's going to merge it on a single line. You can see K0, K0, A0, B0, C0, D0 on a single line. Now, because it's an inner join is like an intersection. That is, when it comes there, K0, K1, is there any K0, K1 here? There's no K0, K1 here. So it's going to ignore this row. Do you understand? Then it comes to the next row. K1, K0. Is there any K1, K0 here? Yes, there are two K1, K0s here. All right, so it's going to pick the first one first. K1, K0, A to B2. K1, K0, C1, D1. And that is the record here. K1, K0, A to B2, C1, D1. All right, then there's still one more K1, K0, right? So it's going to come back again to pick this key, K1, K0, A to B2. Then this is the next row that has K1, K0. So it's going to put this also on a new line. So we have K1, K0, A to B2, C to D2 on a new line. Then it comes to the last, it comes to the last key here, K2, K1. Is there any K2, K1 on this table? There's no K2, K1 on this table, so it's not going to add it. So that's what an inner join does. So you can see that this explanation, this example is really, really showing you how the inner join is actually working. All right. I don't know if did you get that explanation? Did you all get the explanation, or you want me to go over it again? All right. Let me take it one more time, then would go to the next one. So if you are doing an inner join, right, you're looking for the intersection, that is the keys that are common on the two tables, and you're going to put the record on a single row. That's what you're doing. So here, if you look at these two tables, right, we are saying we want to do an inner join on these two keys, that is K1, K2. So you're going to look at these two keys, K0, K0, right? Is K0, K0 on this table? Yes, we have K0, K0 on this table. So we're going to pick this record A0, B0, C0, D0, and we're going to put it on the single line. You can see it's K0, K0, A0, B0, C0, D0. But when it gets to the next record, this is the next record, K0, K1. K0, K1, the algorithm comes here to check if there's any K0, K1. There's no K0, K1 here. So it's going to ignore this. It's an inner join. We are looking for an intersection. There's no intersection. So it's going to ignore this key and move to the next one. The next one says K1, K0. The next key says K1, K0. Is there K1, K0 here? Yes, there are two K1, K0s here. So it's going to pick these two rows and put them on as individual records. So the first row says A2, B2, C1, D1, and that's the first one here. That's on index 1. Then this next one still says it's going to still come back here to say A2, B2, C2, D2. And you can see it here to A2, B2, C2, D2. Now, because we've not exhausted this check, it's going to come to the next row. We have the last row, K2, K1. Is there any K2, K1 here? No, there's no key K2, K1 here, so it's not going to include it. So that's what an inner join does. So it's going to, it does an intersection between the two tables. I believe we understand the inner join now. In this context that I explained, if you're doing an inner join in this context, right? I'm going to have to change some of the keys so that you'll be able to understand better what the inner join, what the inner join implies. So, because I don't want to go back there, our time is fast spent on this particular concept. So that's why let me just go through the next type of join. So we have the outer join. What the outer join does, the outer join takes the union. The inner join takes the intersection, that is the keys, the common keys on the two tables. Those are the keys that are displayed in our output when we do our merge. But on the outer join takes the union of the two, whether the key is there or not, it takes the union of it. And let me explain what that means. Now, this is our left and right. We have this our left table and the right table. And it's still the same syntax, pd.merge left, comma, right, outer. Now, the joining criteria is different. Now, the first one was an inner join. So we have the outer join on, you're specifying the keys that you want to use as the condition for the join, key 1 and key 2. Okay, so the merge function is going to look up the first table, right? K0, 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 right? It's going to take this record and put it on the first row. And that is what is happening here, like we can see, right? This first check. Let me see if I can do a black an highlight on this screen. I can't do that. Okay, let's just continue. I wish I could do an highlight so that I would be able to show you what is really happening on this screen. Okay, so the next row is, it comes back here. That is just the only K0, K0, right? So it comes back to the next key, K0, K1, right? K0, K1, even though it's not on this table, is K0, K1 on this table? No. K0, K1 is not on this table, but it's going to include it because it's a union. Like whether the key is there or not, it takes the union. So it's going to include this particular record, K0, K1, A1, B1, but on, this is it, K0, K1, A1, B1, but on that C and D is going to include not a number that is empty. Not a number means like zero. There's no values, that is empty. There's no value for C and no value for D because it's not found on the other table. Do we understand? Now it's going to come again to the next key. The next key says K1, K0. K1, K0, we have two K1, K0s here. So it's going to list the first K1, K0, A to B2, C1, D1, and then the second one, K1, K0, A to B2, C2, D2, and that is what we have here. You can see them here, these two here, right? That is the next one. All right. So because we are still working on union, where are we now? What's the next one? The next one is K2, K1. Now, K2, K1 is not here. K2, K1 is not here, but because we are doing a union, it's still going to include the K2, K1 would be on that table. But then for C and D, because there is no record for C and D, it's going to put an empty value. And that is why we have this. You can see that we have an empty value. And then there is still one more key left here that has not been taken into consideration. Because we are dealing with an outer join, it's still going to take this last key. And then for A and B, it's going to put empty values for A and B because there's no value for A and B on that particular row. So we have K2, K0. For A and B, we have 0, 0 as your null value, and then we have the C3, D3. So this is what an outer join, does in a merge. When you're doing a merge, it does the union of all the, like you're going to have union of all the values within your data sets. Okay. Okay, so let me just answer these questions because it's kind of related to what I'm doing here. It says that how does it know that it's an inner join if we didn't specify how to be inner or is inner? Yeah, it's an inner join by default. It's an inner join by default. So if we have more than two keys, we do it this way on the number of keys. Yes, if we have more than two keys, just like what I specified here, this is we're having two keys, right? So you have to specify the key 1 and the key 2. That is how you specify your keys. Okay, I hope that addresses that. Now we have one more type of concatenation. We have the join. So the join is also it's quite similar to what we are doing. It's another convenient way of combining columns of two potentially differentially indexed data frame into a single result data frame. So what do I mean? You have this is a data frame. Let me just load them. This is the first data, the second data. You can see that the index of these two data frames are different. You have K1, K2, just like what we've been dealing with, right? K0, K1, K2, K0, K2, K3. Now, for the join does the syntax is the name of, it's not PD.join this time around. The name of the table that is the first table dot join the second table, and by default it does a union. Let me show you the condition of how it does the left. It's a left join. Now this is a left join by default, and I'll explain what the left join means. So what this does is that it takes the first key. Let me load them closer to what I'm explaining so that you can see it. Let me load this tab A, tab B. We have a lot to do today. I hope we are very fast with okay, I think this join is just the key thing. The other one should be very explanatory. All right, so now when you do the left table dot join the right table, so this is a left join by default. And what do I mean? So it takes the first key. K0 is common. There's a K0 on this table, right? So it brings K0, A0, B0, C0, D0 as the first row. Sorry about my ally, as the first row. Then it goes to the next key, K1. K1, it includes all the keys on the left table, right? But then it does not include all the keys on the right table. So that's what the left join does. It's an outer join, but then it includes all the keys on the just on the left table. If we notice that this outer join does like the universal, this one that we did here. There was one outer join we did here. Okay, this one. Yeah. This one does like the union of everything, union of all the keys, whether the key is here or here, it did all of the union. So that left join, okay, I mixed, sorry, I was supposed to explain, there's one more, we have the right and the left join. The right and the left join. So if you understand this, it's going to help you to understand the join function. So let me explain the pd.merge. Sorry about the mix-up. The pd.merge, the right join. We've talked about the inner join, we've talked about the outer. The inner join takes the intersection, the outer join takes the union, that is the keys on both tables, whether the key is there or not in the two tables, it takes the union. Then the right join focuses on the right table. The right join focuses on the right table. And what do I mean? This is the left. I mean, this is our right? And this is the left table. This is the left table, this is the right table. So when you do a right join, this is what happens to the syntax. It takes the keys on, it focuses on just the keys on the right table, and this is what happens. It starts from a K0, K0, C0, D0, which is common, right? That's the first. Then the next one, K1, K0 is here. So it takes K1, K0, C1, D1, K1, K0, A2, B2. And when you come here, you see that actually was recorded K1, K0, A2, B2, C1, D1, right? Then it comes to the next key. The next key says K1, K0, C2, D2, K1, K0, C2, A2, B2, C2, D2. Then it focuses on you see that it has ignored this key because this key is not here. Because we are dealing with the right join, it's just focusing on the keys on the right table. So it comes to the last key, K2, K0, C3, D3. Even though K2, K0 is not here, it still records it because it's a right join, right? So it's like an outer join, but then it focuses on just the right table. So it's going to record K2, K0, C3, D3, but for A and B, it's going to record a null value for A and B, and that's why you have this on the right. You can see K2, K0, the A and B are 0, 0, I mean, null values, and then you have C3, D3. So that's the right join. The same thing for the left join. The left join just focuses on the keys on the left table. And it's similar, just like what we have here. So the left join is going to look like this. K0, K0. Is there any key K0, K0 here? Yes, and that is this key. So it's going to take this and this as a single row. So we have A, K0, K0, A0, B0, K0, K0, C0, D0. That's the first row, 0. Then it's going to come to the next one, K0, K1, A1, B1. K0, K1. Is there any key K0, K1 here? No, but it's still going to include it because it's a left join. So it's going to, we're going to have K0, K1, A1, B1, then null values because there are no elements here that indicates K0, K1. So it's going to register null values for C and D. And that's why you have this here. You can see it's K0, K1, A1, B1, null values. But we have K1, K0, A2, B2 here. Two of them. It's going to take them as two different rows. And then we have K2, K1 here as well. K2, K1, A3, B3. But they're not K2, K1, A3, B3. It's going to register it as well as null values. And you can see the results here. So you see how the left and the right join work. So it focuses on the left key for the left join, and for the right join, it focuses on the right key. So for the join, it works similarly. It's the same thing. It's just that they are just different ways of writing different functions in Python. If you want to use different functions in Python, there are different ways. You can either use the period.merge left join, or you can use this syntax. It's still the same thing. Even for the outer join, it's still the same thing for the outer join. So that is basically about joins. Do we have any questions? Let me see if we have any questions before we move to the next thing we have to do. Okay, so the question says, in one of our classes, we used append. What is the difference between append and concatenation? So append, you use your .append function for lists. You're concatenating two different tables. That's why when you're concatenating, or when you're doing, like, you want to append another list, I mean an element into a list. So you use your .append function. I believe that explains it. So when you're joining two different tables, you use your concatenation. Okay, so let's quickly go over the missing. I want us to work with the real life data before we we go. So let's do this. Let's do I mentioned when we're starting off that we're going to look at joining and concatenation, which we just finished reviewing, and then we're going to look at dealing with missing values. So most times in the data analysis process, right, when you're working as a data analyst or a data scientist, now as a data scientist, your work involves a data analyst job. Or if you're you're working as a data scientist, you also do a data analysis job, because that's actually part of the first step before you go into data science. So as a data analyst, the process, for example, you are given a real life, okay, when we get to that real life example, I'll explain that. But then part of what you'll be doing is you have to know how to deal with messy data sets. In real life, most times you don't have all the data for all your projects. Most times you don't have all your data sets available. Most times you find out that you're having missing values. For example, when you do a survey and then you're asking people questions, sometimes they might not fill some columns, they might not fill some of the rows, they will just leave it empty. So in that case, where like when we're doing our merge, you can see that some of those values are empty, they are missing. So how do you actually deal with them in Python? What do you do to them? How do you deal with them? So that's what we are looking at in this lesson. And usually in Python, missing records are usually denoted as NaN, just like we saw during the merge example. You saw that the missing value was because we didn't have some values on the other table, it was showing us NaN. So we have, it could be in N, capital letter NaN or small letter NaN, meaning not a number. Sometimes in databases, some databases, they might represent it as 0, -1, star, NA, different formats. So as a data analyst, you might be working with data from different sources. So there is this initial stage of data gathering where you have to gather your data, right? And when you're gathering your data, if you're working in a very, very structured and good organization, and they're making your work very easy, they have a database, they have where they store their data. So you just talk to the data engineer, and then they supply you, they give you like access to their database where you can actually, draw your data set from. That's very good. You have minimal work to do. But at times that you need to sort for this data yourself. And that's part of what we'll be doing in our project. So we in this program, we're trying to make our experience as practical as possible, like what you might likely face when you're working. Maybe you're asked to do a task, you're employed and you're asked to do a task. So we'll be working on projects in that line, working with real life data sets. So sometimes you might have to source out for data for yourself. There are several ways to source for data. You could do scraping, you could do web scraping if you're permitted to access some sites. There are some APIs. There are some APIs that you can use to, sometimes you can even scrape data from Twitter, from Facebook, and some of those APIs, right? You can use to gather your data, and then you now have to organize those data in your own format, structured formats, maybe in Excel. So that's another task on its own. So, but then the part of you dealing with missing values has to do with you cleaning your data. There's a process called data cleaning. You haven't gathered your data. You have the data, real life data sets are actually very, very messy. And they come, sometimes some people will write first name and then they write capital letter, maybe all true. Some people will write maybe small letter, starting with small letter, capital letter in the middle, different formats, people writing in different ways. And then you have to deal with all those things as a data analyst. So, but then where we are focusing on is the missing values. So when you're gathering data from a database, sometimes some missing values might be stored in the database as zeros, -1. So you have to understand what formats is your missing value stored, right? So, but in this case, let me just show you how to deal with a missing value. Now, in this data frame, we have a simple data. So for all these examples, I've just been using very, very simple dummy data so that we can understand the basic concepts of how to deal with all of these things. But in real life, it's not actually like this. You see very, very messy data. All right. So you have this table, and then here you can see that the first row, you see that you have one missing value. The second row, you can see you have two missing values. And the third row, you can see you just have all the values are complete. So this can be like, for example, maybe you're filling a questionnaire, you're asking people to fill a questionnaire. And the first column, right? Everybody, this person, student 0 and student 1 filled the column correctly, and but for the last student, the person did not fill anything, so that will be recorded as a missing value. All right, so here, how do you actually deal with it? There are different ways of dealing with the missing value. You can either drop the missing values, but when we get to machine learning, I'll be telling you, for people in the machine learning club, telling you the implication of you dropping records and actually how to really, really deal with those records, because those things impact your machine learning models. All right, so there are different ways. You can drop the missing values, or you can fill it with another number based on statistical analysis, right? So, but then for simplicity's sake, I'm just going to show you how you actually drop the missing value and fill the missing value. That's what I'm going to focus on in this class. I might not tell you why you are dropping it and why you are filling it, because that's beyond the scope of what I'm explaining. when we get to the machine learning class, I cannot be explaining deeper why you're dropping the implications and everything. Okay, so for example, if you have this record, how do you actually remove this missing value from all of the rows? Like you want to remove all of the missing values from the row. So you just call the name of the data frame df dot. There is a function called drop any. So when you do drop any, you can see every row that has a missing value in it, the record gets deleted. I can see that it's just record 0 that is remaining in that data set. So the part of the implication of dropping missing values that it reduces your sample size, reduces your data sets. All right, so you would have to make some decisions and why maybe you have to drop and all of that. But then that's how to drop missing value. Use your drop any, and then you can either by default the axis equals 0. It drops the missing values according to axis equals 0, like that is by row. When in row-wise format, that is, it looks at all the rows and drops all the missing values in the rows. That's the default. But then if you want it to just drop the missing value based off the columns, that in this case, we can see that column A and column B has missing values. Column C does not have missing values. So in that case, you're going to set the axis equals 1. So when you do that, you can see that when you set the axis equals 1, you can see that A and B have been deleted, and then we just have a C. Okay. All right. So those are the 2 ways to drop your missing values. However, what if you want to fill the missing value? You want to fill it with a particular value. Maybe in this case, you don't want to drop it. You want to fill the missing value with something. For example, usually, maybe in machine learning, you have the age colon, and you notice that in your data sets, many people actually didn't fill their age. But when you check the distribution of that particular data set, the ages of people in the data set, you find out that most people they are within the ages of maybe 20 to 30 in that particular column. I mean, in that data set, they are within the ages of 20 to 30. And by intuition, it's just logical to fill it with a median age, because when you did your analysis, by the average age of the people in that data set are between 20 to 30. So you could just fill the missing values with 25. So in that case, how do you fill the missing value in the data set? You use your fill NA method, and then you set the value to what you want to fill it, right? So in this case, you are filling it with the string called field. So I can decide to fill it with a value. I can say I want to fill all of the missing value with 100. And when I do that, you can see that all the missing values have been changed to 100. All right. So that's how to fill your missing values. So that's just simple. I mean, that's a simple case. Now, okay, this is just like what I was explaining. For example, you could check in this column, like in this A column, what if I want to fill the missing value with the mean value on this row? So in this case, I have my data frame, right? This is my data frame 1 and 0. So what I'm going to do is I'm going to find, how do I fill it with the average? The average is what's the mean. So there is a function called the dot mean function. So you can just take the mean, you're going to fill it with the mean of that particular column. So if you come here and say df square, that is remember our selection, when you want to select a row, a column from a database, you could just say dfa, these are all the elements in dfa, dot mean. If you do dot mean, right, you can see that the mean is 1.5. So if I want to fill all the values, I mean, the missing value with 1.5, so I just set my fill any. I first of all select the record, the column that I want to fill, that's the DFA dot fill any. Then I'm setting my value to the mean. It's just like saying I want to set my value to 1.5 instead of using this method. right? And then automatically you find out that this has been updated to 1.5. So I can just say df means 1.5. When you check the original data frame, you see that, okay, it has been updated. I have to put my in place function to be true so that it should be permanent. And then you can see that we have 1.5 as that the value has been replaced by 1.5. I hope you understand this explanation. Yes, we can use concat instead of join, depending on what context you want to use it. You can use concat instead of join. It's possible. All right. So at this point, I'm going to take questions. Do we have any questions? Do we have any questions before? I want us to look at, there is this salaries data sets. Kaggle. So Kaggle is a platform where you have data sets, you have competition. It's like a data science machine learning platform where it's a place whereby you can get to, grow your skills as a data scientist, because here you have a lot of competitions going on, and these are live competitions. Like some companies can even they can consult Kaggle, they can reach out to Kaggle that we want to build a machine learning solution that can you set up a competition whereby you want people that will be open to people, and they will put money on it for people that maybe first, second position, they give them certain money, maybe like 10,000 US dollars or something, or that, depending on the kind of task. So once you partake in that competition, and then you are maybe there's a lead, they use a leaderboard format. There's a leaderboard that they actually use to monitor the person that excels, that is actually leading that competition. And then eventually there is a closing date for the competition. Eventually afterwards, the top maybe 3 persons get a prize, and then they get to share their results with the company. So it's a very, very nice place to be in as a data scientist. So when we're enrolling for this program, I mentioned that we should all sign up on Kaggle. We should create a Kaggle account, so that, because over time as we grow, I want us to do competitions. We can even organize in-house competitions among ourselves, and just to help us grow our data science skills. So why I'm coming here, most times you get real life data sets from this particular platform. So there is a data set column. We're going to work on this particular data set. It's called salaries data set. It's a salary, the salaries of the salary data for San Francisco employees. So we're going to work on it quickly within the few minutes we have. And then I'll show you how to walk through a real life data set. Okay, so that's what we want to do now. All right. Let me just navigate to the place that we will be working on. Okay, so well, let me see if this is the one I actually want to work with. Okay, not this exactly, but let me check for one other one. Okay, let me use this. All right. Okay, I think this is it. All right, so That data set, right, was gotten from Kaggle. And for example, maybe you were given a task as a data analyst to analyze some data sets. And the first thing after, maybe you were supplied, sometimes you may be supplied with a data set. They might tell you, okay, this is the data set, download it from this particular website or something. So in this case, I've gone to Kaggle to download this is where I'm going to download the data sets. So under this platform, this is Kaggle's data set. Then I can just come to this is the code. These are people that have worked on this data set. So I'm just going to come to the data card here, then come here. This is the data sets here. So I'm just going to come here to download it. You can see where you can. I don't want to download it. I have it downloaded already. So I can just download it and then it gets downloaded into my system. All right. So I haven't downloaded it. The next thing is to create a Jupyter notebook for that particular data set. Okay, so assuming this is the notebook that was created, the first thing I'm going to do is I'm going to start thinking, okay, let me investigate this data set. Let me see how the data set looks like. Meanwhile, I must have been briefed on what the data set looks like. Or even if I have not been briefed, I have to investigate myself what this data set, looks like. And in the process of investigating, right, you need Pandas package. So you're going to import Pandas as PD, right? And then now, because the data set is a CSV file, I have to use my pd.read_CSV to read that file. And you remember when we're doing our data input and output, depending on your file type, if it's an Excel file, you use your Excel. If it's a HTML file, depending on the type of the file type, you have to find out how to read in your data set. So in this case, I'm going to read in the salaries data sets using the CSV. So this is the name of the file. All right. So I haven't read it. I'm storing it into style variable. Okay, this is not actually needed here. So I'm going to just comment it out. All right. So now, in the process of investigating, the first thing is that you want to view the data set. You want to check out what the data set looks like. And the syntax to do that is you can use your .ed method. Your .ed checks by default, it returns the first 5 rows of the data set. If I just do .ed, it returns the first 5 rows of the data set. So it's going to show me, okay, this is the way this this data set looks like. Like we have the employee name, we have the job title, we have the base pay, overtime pay, other pay, benefits, total pay benefit, year, notes, agency status, and so many other roles that maybe might be in that data set. But then I have an idea of what the data set looks like. So looking at this data set, you might not really know so much about the data set, but then you would want to go further to check, can I have more information about this data set? Can I know the total number of columns? Can I know the type of data type in each of the columns? And there's another method you can use called the .info method. So the .info method gets the information about the entries available in the data set. So here you can, within the method, if you don't set any defaults, if by default it just tells you the information about the data set. But if you have more than maybe sometimes you might have many columns. Here we just have like 13 columns in this particular data set, right? But then if you have more than maybe 20 columns, you can specify the column maximum number. There are sometimes that you might be working with data set and you can have like 100, 500 columns to work with. So sometimes you might have to break, that's where your merging and all the concatenation comes. You might have to break your data sets into different bits of tables so that you have to analyze them separately to understand what each of this table looks like. So, but here we are working with very, very small data. So here, I'm just showing you that you can actually set your default columns if you want. So what does this information tell us? It's telling us that this is a Pandas data frame, right? And that the total number of entries on this column, on the table, is 148,654 rows of records. That's what we have here. About 148,754. You can see that it's just displaying 5. If I tell it to display 10, right, it will display 10 for me. You can see that I have more values here. I mean, more record here. But then I'm just using, I'm just using this head to view just a sample. I want to see what this looks like. That's what I just want to see. So I don't need other details. So here you can see that it's giving you information about your column. You have total of 13 columns, which are very, very minimal. And you have the ID column, and you have the employee name, job title, and all of that, which you've actually seen here. You've seen all of those things here, right? Okay, great. So, but now another information that is very, very interesting that you need to take note of is the missing values. Here you can see that we have the total number 148,654, but in some of the columns, like here, the base pay, we have some null values. Here we can see that we have about 4 missing values here. 4 missing values. You can see this is 650 and the total is what, 654. So all of, like in notes now, notes, we have 0 values. That is, we have, there's no value for notes. So that column is actually not useful. So you don't even need to include it in your analysis since there's no value for it. So all of this, you can use your drop NA that we talked about, how to deal with missing values. You can use to drop this column here. Status column as well. Nothing is, no information is provided. You don't need it in your analysis, so you can drop it as well. Using your drop NA. All right. So this info gives you an idea of what your columns, your data set looks like. Okay, so afterwards, let's continue and now let's start doing some investigation. Now, you remember that this is like a data analysis task. You now have to start asking yourself some questions. What are the business, what are the interesting hypotheses I really want to find out about this particular data set? This is San Francisco. You want to find out, okay, what's the average base pay of people in that area, right? You can start investigating. So all of these investigations would drive towards something. It can now help you when you want to build data visual, like you want to build a dashboard for this particular data set. If you want to build a dashboard such that somebody that is not really data inclined can just see at a glance and understand that, okay, this is what is happening. So all of this would help you formulate your dashboard development. Okay, so when having this, you can say, okay, what is the average base pay of people in that area in San Francisco? So you have the average base, and how do you get out the average base pay? Now our idea of Pandas selection, indexing and selection comes into play. So how do we get the average, the base pay? How do we get the average base pay? The first thing is to select the base pay column. This is the base pay column. How do you select the base pay column? Who can tell me how to select the base pay column on the charts? How to select the base pay column and find the average. So you have to select the base pay column and then you find the average to get that value. So how do you do that? Can somebody try that quickly? Is anybody attempting? Okay. Thank you, Demeji. Thank you, Bide. Mide. All right. Thank you, everyone. Let's just go right into let's continue so that we can so this is how to select the base pay. We got it, right? Ola, sorry, I'm trying to navigate to the chart. I'm trying to navigate. Okay, Ola Di Meiji, yeah. The name of the data frame is Sal, so please take note of the data frame name Sal, and then also the name of the way the column name was spelled. Also take note of the way the column name was spelled so that you don't run into errors when you're running your code. All right, so we are all on track. So what are you going to do? You're going to do the name of just like we it's been done here, right? But I just had to do everything so that it would be faster. So you pick the name of the data frame, just like what PD and others said. We have the base pay. Now the base pay was written like this. So this is the base pay column. But because we want the average, how do you find the average? That is dot. Use your dot mean method to find the average. And when you do your dot mean, it's going to tell you that this is the average base pay of everybody. So you can imagine that the all of the 148,654, the average salary that they get to pay is 66,325 maybe dollars in a month. I don't know. Or yeah, in a year or in a month. I don't know. It wasn't stated. Okay, I think it's a year. It's yearly. It's a year per year. So they get to pay everybody an average of 66,325. But then you want to also find out what is the max. If you want to go for that, what is the maximum? You can say something like maximum base pay. You know, there are a lot of things to find out from your data set. You can say, I want to check the maximum, I want to check the minimum base pay, right? All of this. So the maximum base pay would still be sal base pay. Sorry, dot max. Then the minimum is actually sal base pay dot mean. This is dot max function. Then you have the dot mean function as well. So let me put it in a print statement so that I'll be able to have the results. Max base pay is okay. You can have the max base pay is this, and then the mean base pay is this. Then I'm putting it in a print statement so that we'll be able to do it properly formatted. All right, so we can have this. So you can see that the maximum base pay is so, and then the minimum base pay is minus, you can imagine the maximum base pay is 319,000 plus USD per year, and then the minimum is minus 160. Is it possible for them to pay somebody minus 166? Then you'd be wondering, who is the person that they're actually paying? Is the person actually owing, or is the person having a loan? Or, you know, it calls for further investigations as a data analyst. So as a data analyst, you tend to like make a lot of inquiries. You have to find out things from your data set, because all of those things that you're finding out would inform something to your maybe your business executives and also to people that actually want to use the data. Okay, you can't see my screen. My screen is visible. Maybe it's a network. Can you see? Can you all see my screen? Can you all see my screen? All right, great. I think it's your network. If you can't see my screen. Okay, so let's just move further. You could also find out that, okay, do we have overtime pay in this data set? What's the highest overtime pay? Who is the person that they actually paid the highest overtime money? Then you can investigate. How do you get that? That's simple to get. Sal overtime pay dot max, right? That's very easy to get. Now, this is a question that we can further ask, what is the job title of Joseph Driscoll? Note, use all caps, otherwise you may get an answer that does not match up. There is a Joseph Driscoll that is not in capital letters. So can somebody try to find out the job title of Joseph Driscoll from this data set? The job title of Joseph Driscoll. Can somebody write the syntax? The job title of Joseph Driscoll. Can somebody attempt that one in the next 1 minute? The job title of Joseph Driscoll. Joseph Driscoll, all capital letter. The job title of Joseph Driscoll. Because of our time, I want us to move fast, so I'm just going to go right into the name of the data set is Sal. All right. The name of the data set is Sal. The job title of Joseph Driscoll. Let me wait 1 more minute. All right, because of our time, let's just proceed. So to get out the job title of Joseph Driscoll, you need to, let me go down to, okay. Let me just add this. So there is a name, there's somebody that is called Joseph Driscoll in the data set. So the first thing is to find out, how do you get out the name of Joseph Driscoll? That is, you have to find out that Sal, where the first name or the employee name, right? The employee name is equal to Joseph Driscoll. That's the person I want to first of all filter out the person's record. I want to get out the person that is named, the employee name is who? Joseph Driscoll. Remember when we're doing our selection, this is Joseph Driscoll. So you're going to get out Joseph Driscoll's. Okay. Now, Sal, employee name Joseph Driscoll. So I have to, the first thing I mentioned then was you have to write the condition. This is the condition we want to get out. Then you have to enclose it in a bigger data frame, right? And now you can see that it has filtered out just Joseph Driscoll. Do you understand? Now, but what the question is, what is his job title? I don't want all of the old record. I just want the job title. And how do you do your selection of a single column? You enclose it inside a square bracket, and then you put the name of the column name, and that's his job title, right? When you do that, you can see that Joseph Driscoll's job title is Captain Fire Suppression. All right. So I hope that helps, clarify some things. Like she see the connection gradually, right? Thank you, Oladimeji. Okay, thank you. Thank you for that. Thank you, BD, as well. All right, thank you for that. It's a double equation mark because of the you're not equating, you're actually looking for equality sign. I mean, it's not an equality sign, you're comparing the employee name to Joseph Driscoll. So you're going to use a double equals to. Okay, so let us look for another condition. Let's try to find out some other information about the Joseph Driscoll. Okay, let's ask how much does Joseph Driscoll make including benefits? That is, what is the total benefits of Joseph Driscoll? Now that we found out about his job title, can we find out about his total benefits as well? You could just include your total benefits here. Total benefits. And you know, when you're selecting two columns, what do you do? You put it in a double square bracket. Okay, my key is wrong, my spelling is wrong. Total paid benefits. Okay, that's what I'm supposed to use. Total paid benefit. All right, so when you search, you can see that Joseph Driscoll's total pay benefit is 270,324. Okay, so you could do some further investigation about him. Maybe you're asked to find out some other things about Joseph Driscoll. But let's just move further and look at other things about the data set. Okay, so we want to also know that person that is actually the lowest paid, that is having minus. What is the name of the person? What is the person's job title? Why is the person paid that low? You understand? So let's do some further investigation about that person. So if we want to get out the name of the lowest paid person, how do we go about it? What's the first thing to think about? The name of the lowest paid person, including benefit. Let me read out the data set again. The data set is Sal. Now, this is the data set. Let me just do sal.ed so that we have a very small data set. Now, they said, what is the name? The question we're trying to address is, what's the name of the lowest paid person, including benefits? That is, we want to know the total the name of the person and its benefits, right? That's the question. The lowest paid person. So how do we get that out? Now, when you hear lowest paid, the first thing that comes to your mind is the person's salary. So you have to find out the minimum salary first. That's the condition. You have to find out what is the minimum, the lowest salary. Then I haven't found out the lowest salary. Then you have to get out the name of the person with the lowest salary. So that's the way to think around it. When you're faced with a question, you look at the simplest case that, okay, how am I going to get to the answer? The first thing to think about is, because if you just say, I want to get out the name, we have a lot of names there. So what would help you filter out that condition is actually the lowest paid person. So we're going to get out, the first thing is to what? Get out the person's, the lowest, the minimum pay, the person with the minimum benefits. And that is, how do you get that out? You can just say SAL, total pay benefits. Because I said including benefits, right? The total pay benefits dot mean. So now we've seen that the total pay benefit dot mean is minus 16.13. But we want to find out that who is this person that has this salary? Now, the next thing is, how do you actually get out the person's name that has this salary? So you have to check you have to use a condition that is, I want to filter out the name, employee name, right? That has the minimum salary equals to this. That's what you're trying to filter out. So how do you get that? You're going to let's get out the whole data set first. You want to find out you want to filter out the total pay benefit, the person with the total pay benefit. Let's get it out first. So first of all, we can just set this person as the minimum pay equals to this, right? Then you can now say that can I get out the total pay benefits that is equals to the minimum pay? But then you have to enclose, I want to get out the record of the total paid benefit that is equals to the minimum pay. And when you do that, I think there is an error somewhere. Let me check. Invalid syntax. Okay, so you can see that you're not supposed to use equals to, you're supposed to use your comparison operator. Now you can see that I've actually gotten out that person's name because I used the total pay benefit to filter the person. So there's the person called Joe Lopez, and you can see that is a counselor, log cabin ranch, but his minimum pay, I don't know why he's having minus in both his other pay, total pay, and his minimum pay is actually minus 618. So from here, you can actually retrieve the person's name by saying, I just want the employee's name. And then here you can now load it and see that it's Joe Lopez. That's actually the person with the minimum pay in that in that particular data set. I don't know if you're following these explanations. Oh, I saw your hand. I'll take your question. Let me just try to cover some other basics before we close. All right. So you can keep asking a lot of very interesting question. Now, another thing you can do, I taught you group by and group by when we talked about group, how you grouping particular records together based on a particular aggregate. Maybe you want to group in by year. You want to find out a particular aggregate based on a particular condition. You can use group by. Maybe you want to find a group of when we're giving the explanation of Google, Microsoft, and Facebook's data. Here, now you can also use a group by to find out the average mean of all the employees per year. For example, you want to know how much do they pay all their employees every year, and what's the average mean salary for each of the year, and that's where the group by comes in. So you can use your group by function to group each of the year. You can say solve group by the year, then I want the mean. If you just do the mean alone, it's going to give you the mean of all of the data sets in all of the columns in that data set. So, but then I just want the base pay of each of the year. So you can see that in 2011, the average base pay they paid people was 63,595. You can see that it increased in 2012. It further increased in 2013, but it dropped in 2014. Then you might be asking questions that, okay, is it inflation or what is the cost? Why did it drop? And other further question investigations regarding that particular data set. All right. So moving forward, you've been able to identify that. Let's just move forward to, look at other things like what are the unique job titles we have. There's this command called the N unique. You can see that there are 259 job titles in that particular region in San Francisco. Then you have you can do a value count of each of those job types. You can see that the training or transit operator, we have about 7,036 people that are transit operators. So you can say that people in San Francisco, most of them are actually transit operators. Then you have half of those people special nurses, registered nurses. So you have few people that are actually having other specialized occupation in that region. So you can also find out the top most common job using your value count. Let's just take the top 5, because when you do the value count, it arranges each of those job titles in descending order. So based on their aggregate, this one has the 20 transit operator has the highest number of job titles, followed by special nurse, registered nurse, public, and all of that. So you can find the first 5 common job titles using your .ed function. And then you can see here that we have nurses, transit operators, public workers, and then police officers as the top 5 jobs in that region. You can also, there are several, things that can, you can begin to investigate in the data set. You can also say, okay, how many job titles were represented by only one person in 2013? So you can see that all your knowledge of Python, all the Python scripts and the group by, the merge, all of that comes into play, the selection, the indexing, all of that come into play in you analyzing your data. Because if you don't actually know those things, you might not know what to do when you are faced with a particular question. You just be wondering, okay, how am I going to do this? What am I going to do? But even if you don't know what to do, right, you have to, there's something called algorithm. You have to break down your question. Like if you are faced with a complex, for example, you have this complex question, how many job titles were represented by only one person in 2013? That question is very, very vague. So now that tells you, okay, what am I going to do when I'm faced with this problem? How can I count the number of job titles that were presented by only one person in 2013? The first thing is for me to filter only all the 2013 records. Because in my data set, I have 2013, I have 2011, I have 2010. I don't want to know about other years. Can I first of all get out all the records of 2013? That's the simplest case that that's what I'm going to do if I'm faced with this question. Having gathered all the 2013 records, I'm going to write the code. That's the first step, to solving this problem. How do you gather all the 2013 records? You just say, can I get out the year? That's the condition. Salary year equals 2013, right? And when you're getting out your condition, you have to enclose it in what? In a square to get out. Now I have all the records of the 2013 people. Now, the next simple case is, they said how many job titles were represented by only one person. I have to count the number of job titles in 2013. That's the next step. So here I'm going to save this. This is a new data set. So I can just say JT 2013 equals to this. This is my new table. So my new table is JD 2013 equals to this. So the next thing is that how many job titles were represented by only one person. So I'm going to get out the job titles of everybody, right? I'm going to do a value count of all the job titles in this data set. Sorry, let me just copy this. The name. So when I do the job title, how do I get out the job title counts? I'm going to use my value counts. Job title dot value counts. Now, job title dot value counts is giving me the number of job title for we have transit operator 2295, special note, and all of that. But I just want those people that their job titles are just one, like this general utility mechanic, adults, all of adults, probe, OFC, mayoral staff, and all of that. I want only those people that their job titles are represented by only one person. So what's the next step? What do I do going forward? The next thing is to equate, that is, I haven't gotten the job value count. I'm going to set this as another condition. I want the ones that are equals to just one. Those are the people that I want to get out their value. Can you get me out all of the value count equals to one? So you can see that those ones that are equals to 1 are true. And this is a condition. I'm just going to, I'm going to take the sum of all of those truths to get my answer. And that tells me that 202 people have their job titles only represented by one person in 2013. You can see the thought pattern. You have to take it step by step before you get to your desired results. If not, you just be confused. Okay, what do I do? Where do I start from? You start from the simplest case, and then you drill down to the specifics. All right. Our time is fast spent. I want to take questions. So if we go through this next one talks about how many people have the word chief in their job title. You see, that's another question to find out. In this case, this is where you have to use your function. Now, when you're doing your analysis, there are sometimes I might face some complex question that you might have to use a program, like you have to use a for loop, you have to use a function, you have to create your own function to solve that particular problem. That's where all of what we've been learning comes into play. So in this case, you have to use a function to filter through each of the job titles to check the people that have chief in their job title using all that we've learned before now. I'd solved it here using 2 options. So it's okay. Let me just, because of for the sake of the record, let me explain one of the ways to do that. Now, for you to find out the people that have the word chief in their job title, you have to do a count using you have to do you have to do a loop. You have to loop through each of the job titles in that data set. And if you want to loop through each of the job title, right, it's like you have to write an if statement. You have to check that, okay, if the first job title has chief in it, right, you can say, you can write register yes, but if it does not have chief in it, write no. So that's a way. That's a way to go about it. You can loop through each of first of all, get out all the job titles in that data set, all the old job titles. Then you have to loop through each of these data sets. Check, is there chief in this data set? If there's no chief in this data set, ignore this row, move to the next one. Is there chief? Then you do a count of all the people that have chief in the data set. So what I did was that I wrote a simple function. Given that I created a function called chief string, and then this function is going to check if chief is inside this job title. And for me to check it, I have to convert all this, this job title, they are in capital letter because of the way people write their responses. Some people might write capital letter CHIF. I want to take care of all the possible scenarios. So the next thing is for me to convert every character, every of the job titles to lowercase. When I convert every of the job titles to lowercase, it will be easy for me to search for chief in that particular job title. So I created a function called chief string that takes in the title name, and then I check if chief is inside the job title dot lower, that is, I've converted this job title into a lowercase, then return true, else return false. So that's the first step. This has not solved the problem, but that's the first step. Now, I haven't created this function. Let me use this function. And how do you use a function? Chief string, I can write I am testing this. Now, inside this I am testing this, there is no chief, right? It's going to return false. But if I write I am testing this chief, it's going to tell me true, because I've already taken care of all the cases of. So what it's going to do is that it's going to take in this title and check, is chief in this string? It's going to convert this string into lowercase. Then it's going to ask, is chief in this string? If chief is in this string, then it's going to return true. So now it's easy for me to use this function on my data sets now that I see that my function is working. So to use the function, I have to count. Now I'm going to get out all the job titles, right? I haven't gotten out all the job titles. Then I'm going to do a count such that there'll be a counter that will be helping me to count the number of truths in that particular string, in that particular function. Now I'm going to say this sum is my counter for all the elements in this job title. If chief string, that particular job title, if chief string is that particular job title, add 1 to my counter, else continue. So that is, you can see all of the for loops that we've been using over time. Now, how we are bringing it together, for loop here, we're using a for loop, we're using an if statement, and we're using a continue. So this continue is telling us that else, if it's not there, that means we should still go ahead with the for loop, but ignore the next, that step that is not there, that step that is indicating false. Ignore it and just count only those ones that their job titles are have chief in it. So when you do that, it does a loop, it searches through all of this job titles and returns at the end of the day, it prints out the sum and tells me that we have 627 people that has chief in their job titles. So that is a way to do that, question, to solve that question. I know that understanding this now, but maybe if you go through the recording and you go through it over and over again, you would understand. And when you go through previous recording as well, you understand what I am explaining. But this is just like what a typical real life analysis might look like. It's always very, very very tricky, and then you need to put a lot of concepts, everything that we've been learning, put it together, and then you see that and it's by using, the more you solve problems, you're working with different data sets, you come across different data and data analysis tasks, you find out that you get a lot better in what you're doing. At this point, I would want to stop. The question says, please, how do we get the notebooks in the correct format from the LMS? Okay, so there is this video on the LMS where I showed how to download the notebook in the correct format. Just go to June 2nd on the LMS. Under FAQ, you see a video, watch the video, you see how to download the notebook in the correct format. Okay. Do we have any other questions? Somebody wanted to talk. I don't know if he's still here. I think he has left. Do we have any questions? Any questions? Do we at least understand? How well do you understand this concept from 0 to 100? You can drop it on the chat. Let me have an overview of how well we understand. 0 to 10, rather. 0 to 10. Just drop it in the chat. How well do you understand this concept? Okay, that's fair enough. Oh, okay. If you don't understand it, I can totally understand, because there are some concepts that you need to just, go over it over and over and over again. Then you find out that, oh, okay, so this is what it actually means. If you have to go over the functions video again, please. Function is very, very key. When you're doing data analytics, you have to know how to write functions. You have to know how to use your loops, your for loops, your while state, if statement, if else statements, your while loops, your break, your continue keywords. That particular video, please watch it very well. If you don't understand some concept, you can reach out or explain again. I'll explain further. Yeah. please try to just go over this because these are typical. This is a very, very simple case, right? Because there are some times that you might be faced with very technical questions, and there are some business cases that are very, very, it's not straightforward. You have to find out and start investigating. But the truth is, as you try your hands on simple concepts, just try it bit by bit, you find out that you get better. You get it's just like logical reasoning. As you're thinking, you're understanding better, and then you get better at what you're doing. Okay, so if you don't understand everything now, it's not a problem at all. You'll get to understand better as you use this. But it's just for you to know the flow. What are you to do at every point in time? That's very, very key. And this is not the end of data analysis. So on Wednesday, I'm just going to take you through like having gathered all of this, your findings, you have to, as a business intelligence expert now, you have to translate, okay, how are these results going to impact the business that I'm actually dealing with? How am I going to report this problem? Because surely your customers or the people that you're actually dealing with, they don't want to know the codes you've written or how you came across they want to just see the results. They want to see the front end. They want to see what relates to them, how it can help them. All right. So for our project, we'll be working with real life data, and I'm going to make it in previous cohorts, we kind of streamlined what you work on, but then I want you to work with any data for this cohort. I want us to work with anything that interests us so that we don't try. I know we're coming from various backgrounds. So I'm going to be providing with data sources where you can get data. And then you work with different data sets. If it's transport data, population data, but I'm going to show you guideline what to do and how to go about it so that it will be clear what to do. All right. So at this point, I don't want to take much of our time. Thank you all so much for joining. And I do hope that all of these things that you're learning, you're going to put it to good use, because that's part of the essence of doing all of this. You can't invest this so much time into all of this and then you just push it away. And, when you use it, these skills are very, very key skills that a lot of businesses, they are looking out for. There are times that you might even go to some places, analyze their data. You can tell a story about a particular maybe company, get their data, and they'll be excited to see, oh, okay, you actually did this for us. I think we need to know more. We have more data. Can you work with us? They can give you a contract, and then you can, that's how you get into real life data and what you actually want to do. All right. So I'm going to leave you all at this point. Thank you all so much. If there are no questions, so that we can release some people, but most persons have been working all through the morning. Right. Okay, today's a public holiday. Yeah, so but then some people have been working. All right, so I'm going to release us now. If you have any questions, you can drop it. Would address it on the Telegram group. Please, when we are joining, let's try to join on time, and then join with your name, the name that you used to register. Please join with the name, and also or your email address. I don't know the person, we just allowed you in, but the name is like an Arabic name and we can't actually trace your name. So, but next time you're joining, please try as much as possible to join either with your email address or your pure heart. Yes, I think you are the one, right? Yeah, just try and join with your name. All right. Okay. Your full name or your email address. That would do to trace who is joining. All right. Have a wonderful evening, everyone. See you on Wednesday. Bye for now.